8M2 lesson 5. Here we go. We're going to talk about rotation, the definition of rotation and basic properties. This is the third of our rigid transformations that we will learn about in Unit 2. So let's cut over to our magic chalkboard and let's look up here at our at the drawing of these two. I call them whistles. They look kind of like whistles. And we're going to think about, what can we do? Is there a transformation that we've used so far? What have we learned so far? Let's just write those things down. That one is translation, which is like sliding or moving. And two, we had reflection, which is like mirroring. And today we're going to learn about a third one called rotation. And the question here is there a way to get from image number, if this is image number 1 and this is image number 2, is there a way to get from 1 to 2 using translation or reflection? And the short answer is no, because if we start and if we look at this image here, there's no way, we can't just move it. Remember, moving only keeps the orientation. There's no way we can move it to get to image number 2. And if you could probably also convince yourself that there's no way to reflect it. There's no way I can build a mirror image where if I stuck this thing anywhere and then laid down a mirror that I could get to the second image. So the last thing we can do is going to be called rotation. And watch how this works. I'm just going to show it to you real quick. And if we take this guy and we watch what we do, I'm just going to rotate this guy upwards. And notice how if we rotate it, we get the right answer. So what we've done is we've taken this object and notice how we're just going to twist it up like this. And we're going to get our answer. And so what we've done here when we've moved this whistle, we've moved it, we've transformed it using rotation. And notice the key on rotation. When we translation, let's just remind ourselves, translation, we move along a vector. And when we reflect across a line. We mirror across a line. When we rotate, we're going to rotate a number of degrees about a point, right? So translating, we use vectors to translate. This is a vector. Reflection, we can reflect an object along a mirror or a line. And when we rotate, remember, we're going to have a point. Notice our point, which is right where that X is. And then we have a number of degrees. And you'll notice we start with 0 degrees and then we go 1, 2, 3, 4, 5, and around as we would rotate around a circle. And if we went if this is where we start, that would be 0 degrees. And if we went all the way around, that would be 360 degrees. And that's how we define rotation. So let's look at some more examples of rotation. And what we're going to do is I'm going to show it to you using this other program called Geogebra. So this is our program called Geogebra. And just a second, I'm just going to make sure you see what I see. I'm just going to just confirm that. Yeah. Okay. So you're seeing what I'm seeing. Okay. So in this case, we're going to take this triangle and we're going to rotate it around this point D a certain number of degrees. And now one thing to notice is if you go counterclockwise, that's going to be positive. We're going to call that positive degrees. So check this out. And if we go clockwise, it's going to be negative. Why clockwise is negative and counterclockwise is positive? It's just the way they decided to define it. It's kind of like to the left is positive, and to the right, if you're looking from the point of rotation or the axis of rotation, and you go to the right, it's negative. So I don't know. Counterclockwise positive, clockwise is negative. You're just going to have to memorize that. Now notice if we rotate something 0 degrees, it's sitting on top of itself. Okay. Now what we can also do is we can rotate it 90 degrees. And if we rotate that thing 90 degrees, and I'll show you how to do this, it's kind of a quarter turn clockwise. And if we go 180 degrees, we've gone all the way around the point. So it's all the way on the other side. Now notice this is not a mirror image. This is a rotation. And we can just, let's just look, we'll just set this thing up, this slider up so that it goes all the way to 360. So if we go all the way to 360, as you might expect, where do you think you're going to end up if we get to 360? If we rotate 360, we're back to the beginning. Okay. Now notice we can also change our point. We can change our point of rotation. We could, if we make this thing closer, notice how when we rotate, the object stays closer. And if we make it, whoops, sorry about that. Go to 0. Let's go to 0. Okay, but if we make this point really far away, when we rotate, we're rotating around that point. So the object's going to move further as we move it around. So I just wanted to show you this. Now you can also, you don't just rotate, you don't just rotate triangles. You can rotate other objects. So let's delete this object here, and let's make ourselves a crazy polygon just for fun. We can make it like this, and we can say let's rotate this guy around D, and we're going to rotate that on the slider too. Whoops, we want to rotate. Let's see, we want to rotate. Let's undo this. We're going to say we want to rotate around a point. So we're going to select this, and then we're going to select this point, and then we're going to move that. Okay. So there we go. So if we're at 0 degrees, we can rotate it around point D. And if we move point D closer, then our rotation stays tighter. Let's get rid of all these other guys. You can fast forward past all this if you'd like to. I'm just going to do a few more rotations by moving our object in a few different, our point of rotation in a few different locations. And you can even move the location of rotation right into the middle, and the object will just twist on itself as you move around. Or you can move the point of rotation up above. So that's GeoGebra. All right, next. And yeah, hopefully this helps you understand. It gives you a better understanding of what rotation is. I haven't shown you or truly defined rotation yet, but I've just kind of showed you examples of how you rotate and what rotation is. Rotation is twisting or rotating. And that's the third of our rigid transformations. Now, let's go back one more second, and I want to show you one interesting thing about. Let's talk about our properties of rotation before we move away, and I'm going to show you how to actually do your own rotations. The first point is that objects. Well, let's go back to Sketchpad real quick. And we're going to have the properties of rotation. The properties of rotation. And these are going to be the same properties as we had for reflection, parentheses, same as for reflection and translation. Same. The first one, you map line segments to line segments and angles to angles, and also rays to rays and lines to lines. The second is line segment lengths are preserved. And three are angle measurements are preserved. So let's look at all three of these. Maybe you take these down in your notes, write them down. Maybe take a screenshot and watch as we go to this other screen and verify. So the first thing we want to look at is let's look at every line segment over here will have an equivalent line segment on our rotated object. So line segment AK there's an A prime, K prime. Line segment GH, the one on the inside here, kind of the inside. GH, there should be a G prime, H prime on the inside over here, and there is G prime, H prime. There's a JI, an IJ, a really long one on the outside, and there's a really long one, I prime, J prime. So for each line segment we have on our original will be an equivalent one on our rotated object. Second, we have line segment lengths are maintained. If you want to measure line segment JK, it'll be the same as line segment JK over here. If you want to measure GF, it will have the same length as G prime, F prime on this side. And similarly, if you want to measure these angles, let's just do this. BAK and BA prime, K prime. Let's see if we can measure these angles. Let's take this angle and let's go KAB. And that's, let's do it the other way. Let's measure the angle this way. BAK. And that's 104 degrees. 104 degrees if we do BAK. So let's measure angle BA prime, K prime, and it's 104 degrees. And so if you go through and you measure any one of these angles, it'll be the same. We can do GH I 58 degrees, and go G, H, G prime, I, H prime, I prime, and we get 58.7 degrees, just the same. Okay, so coming back, these are our properties of rotation. When we rotate an object about a point, these three properties will always be true. Okay, now I want to show you how to rotate. Now, what you need to have in front of you is a piece of paper. And I'll show you this. So here we go. So here's our paper that we're going to, our original object, and then we're gonna learn how to rotate this triangle about this point. And what we're gonna need is we're gonna need some tracing paper. Probably should have mentioned that up front. You can probably do this with another piece of paper, but if you're doing it online, you're not really going to be able to see it. So that's why I'm using tracing paper. If you have tracing paper, it's the best, but you might be able to do it with two pieces of graph paper. Okay, so the way that you do a rotation is you're going to lay your tracing paper right on top of your other paper, and then you're going to draw the point and the object that you're going to rotate. Okay, so I'm going to do that right now. I'm going to put this down. I'm going to, on my tracing paper, trace my object and trace my point of rotation. And I'm going to label I'm going to go back and I'm going to label my objects. So here's my original A, B, C, and we're going to label that across the top here, A prime, C prime, B prime. Now, when we rotate, the next thing we're going to do is we're going to say we have to define how much we want to rotate by. So I want to rotate by 90 degrees. So I'm going to go to my original drawing here, and I'm going to identify 90 degrees. And I'm going to pick any one of these points to do that rotation. So I'm going to pick point A over here, and I'm going to draw a 90-degree angle off of point A. So 90 degrees, and I'll show you that here in a second. I'm going to make a 90-degree angle, and I'll use do this one in pencil. "90-degree angle." You should be able to know. You should know how to make a 90-degree angle. So here's my 90-degree angle, and I made that angle, and that's a right angle, so I will annotate it as a right angle. And you should know how to do that from 7M5 maybe. It's a lesson from last year. And so now all I'm going to do is I'm going to take my tracing paper and lay my object back over the top of it, and I'm going to twist it until my A prime is on top of my angle, my new angle. I'm going to leave my point X has to remain on top of my point X, as you see here, but my A prime is now on my line, right? We originally started off like this, where A prime was on top of A, and now I twisted, I kept X on top of X, and I twisted until A prime was on top of my new line. See? And so what I've done is I've rotated my object 90 degrees. Pretty cool, huh? Okay. And you could have done it 45 degrees. 45 might have been something like right about here. 0 degrees would have been here, all the way to 90 degrees here. And you could have kept going, 180 and all the way around to 360. All right. So that's the process. Now, what I'm going to ask you to do is have you do a practice problem, and this will be our homework help. And that'll be the rest of the lesson, because this is the way that you are going to learn. This is one of the homework problems is going to be dependent on you knowing how to rotate. Rotate using tracing paper. Okay, so let's look at our homework helper. So homework help. So what I'm going to ask you to do is I want you to draw a quadrilateral A, B, C, D, something like this. I'll help you kind of get started here. And so we'll label this A, B, C, D. And it doesn't have to be exactly like this, but maybe make it something like this. And then make a point O that's below it. And we're going to rotate A, B, C, D, quadrilateral ABC about point O, 100 and, well, let's do it 60 degrees. About 0.0, 60 degrees. And remember, 60 degrees is going to be, it's going to be in this direction. Right? It's going to be, right, 60 degrees implies, because it's positive, it's going to be counter clockwise. And use tracing paper. Use the tracing paper method. Okay, so now you pause and try. And then I'm going to also ask you some questions. When you use the tracing paper, remember to label your new points. A prime, B prime, etc. And question A is, what is difference in length of segment AB and segment A prime, B prime? And then B, what is difference in measure of angle ABC and angle A prime, B prime, C prime? Okay, so you pause and you try, and I'm going to do the same experiment or the same problem here on tracing paper. And you can just fast forward past all this. While I do my drawing, and hopefully you can pause and be trying the same thing. I'm almost done. I'm sitting here drawing the same thing that you're drawing. I probably should have had this already done, but I didn't. But I'm almost there, getting very close. I'm drawing. I'm using my tracing paper, drawing. And I'm almost done, and we will see how we do this problem. When we said we want to make it 60 degrees, so we're going to make a 60-degree line. Okay. So we're back on our Hangout. Hopefully you did this exercise, and so on the bottom here I have my my quadrilateral ABCD, and I have chosen. So I drew my ABCD. I chose a 60-degree angle. A 60-degree angle off of point D. I made my tracing. I put it straight on top. And now I'm going to twist my point D, D prime. I'm going to twist, 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 twist down until it's on the 60-degree line. And now I have a object that has been rotated 60 degrees around point O, and it's still the same quadrilateral. Now, remember the questions. What is the difference between a line A, B, and A prime, B prime? And the answer is they are the same size because rotation maintains line segment length. And the other question was, what is the difference between angle A, B, C, and angle A prime, B prime, C prime? And the answer is no difference. The angles have to have the same measure. Okay. So this video was a little bit different than the rest. We used a new software, a website called Geogebra, to show you how to do some rotations. You could use Geogebra to do your rotations, but in class you're probably not going to have access to that website. So you can use rotation on transparencies, which is a great way to do your rotations. And otherwise, maybe your teacher has some other tools that you can use. Hopefully this was useful. Enjoy your homework, and we'll be seeing you on lesson 6, 8M2 lesson 6 shortly.